All right, today we're going to solve three different types of log equations. Type 1 is when we have a logarithm equal to another logarithm. If you have two logs and they have the same base, then whatever you're taking the logs of have to be equal. All right, so if I had like log base 3 of 2x equals log base 3 of 8, since they have the same base, I could say 2x equals 8, and then x would equal 4. If I had log base 3 of 2x equals log base 5 of 8, though, I would say I can't solve that problem because they don't have the same bases. Okay? So looking at our first example, log base 4 of x plus 3 equals log base 4 of 8x plus 17. Since they have the same logarithms with the same base, the logs would cancel out, and I could take x plus 3 and set it equal to 8x plus 17. Now, just solve that equation. So we need to move our x's to the same side. So 3 equals 7x plus 17. And we need to move all our numbers to the opposite side. So negative 14 equals 7x. And when I divide by 7, I get x equals negative 2. So checking out part B. I have log base 2 of 2x minus 1 equals log base 2 of x plus 5. Since they're the same logs, the logs will cancel. And I can set what I'm actually taking the logs of equal to each other. So then I move all my x's to one side. So 2x minus 1x is 1x. Minus 1 equals 5. And when I add 1, I get x equals 6. Now that is the easiest type of logarithm equation to solve. The next set, type 2, is when I don't have a log on both sides. I want everything that has a logarithm on the left and everything that just has a single number to the right. So if I have log base 4 of x plus 3 equals 2, you have a single logarithm. Rewrite your logarithm as an exponential. You have the base, you have an exponent, and you have what it equals. So if I rewrote log base 4 of x plus 3 equals 2, I would have base to exponent 4 squared equals x plus 3. That uses our rule from day one of logarithms. If you have a log, can you write it as an exponential? Okay? So what is 4 squared? 4 squared is 16 equals x plus 3. Solving for x equals 13 then. So even if I have a fraction, if I have a logarithm and it's all by itself and it equals just a single number, not another logarithm, rewrite it. 16 to the 5 halves equals x. Well, x is by itself. Type that in your calculator. 16 to the 5 halves is 1,024. So that's type 2. Taking a single logarithm that's equal to just a number and converting it. All right, the last type of solving uses our properties of logarithms. So condense everything that's on the left, condense everything that's on the right using our rules. Remember, addition and multiplication go together, subtraction goes with division, and a number in front becomes an exponent. Then you should have a log equal to another log, and then it becomes a type 1 problem. The logs would cancel out and you would just solve the equation. So looking at our first example, log base 4 of 48 minus log base 4 of x equals log base 4 of 6. You have two logs over here that we need to condense. So I need it to be log base 4 of something. Well, since I have a subtraction, I know I'm going to have something divided by something. Well, the first thing I have is 48. Subtraction becomes division. So I have 48 over x, and that condenses the left side. And that equals log base 4 of 6. Well, now that I have a single log equal to the single log, and they're both log base 4s, what I'm taking the log of can be set equal to each other. So 48 over x equals 6. We need to solve this for x. So I need to get rid of this fraction. I'm going to multiply both sides by x. So 48 equals 6x. Dividing both sides by 6 gives me x equals 8. 48 divided by 8 is 6. All right, looking at B. 3 log base 5 of x minus log base 5 of 4 equals log base 5 of 128. I have a single log on the right, so I'm good. I know I'm going to have something equal to log base 5 of 128. But on the left, I have multiple logs that I need to condense. So starting with the 3 in front, that would need to come up as an exponent. Log base 5 of x to the third minus log base 5 of 4. And then I know subtraction becomes division. So I have x to the third over 4 equals log base 5 of 128. And what happens when I have a logarithm equal to a logarithm? And they have the same bases, they're both base 5. The logs cancel out, and I would have x to the third over 4 equals 128. Well, let's solve this for x. I'm going to multiply both sides by 4. So x to the third equals 512. So how do I get rid of that exponent of 3? I could take a cube root, or remember, I could always write an exponent as a fraction and then flip it. So x would equal whatever 512 to the 1/3 is. 512 to the 1/3 is equal to 8. So x equals 8. All right, let's try another one. 3 log of x minus 5 equals log of 64. Well, it almost looks like it's a single log. However, there's a number in front of a log, and I know a number in front of a log needs to be pulled up as an exponent. Because I needed to say logarithm equals a logarithm. So that 3 comes up as an exponent. Now that I have a log equals a log, and remember these logs all have a little base of 10, so they do have the same base, the logs will drop out. So x minus 5 to the third equals 64. And again, I can't distribute that 3 in, that's an exponent. I can't touch the x minus 5 until I get rid of that 3. So that goes back to, let's get rid of the 3. I can cube root, or I could take it to the 1/3. So x minus 5 equals 64 to the 1/3, which is 4. And now that I have that parentheses broken free, I can go ahead and add 5 and get x equals 9. Okay. Last one. Log base 10, because there's no number there, of 2x plus 6 minus log 5 equals log 12. I have multiple logs over here. I have a subtraction, so I know subtraction condenses to division. So log of 2x plus 6 over 5, because subtraction means division, equals log of 12. So 2x plus 6 over 5 equals 12, because the logs would cancel out since they're both logarithm with base 10. I need to get rid of that fraction. So I'm going to multiply both sides by 5. So 2x plus 6 equals 60. 12 times 5 is 60. Those 5s would cancel. Solving this, 2x equals 54. Dividing by 2 gives me x equals 27. So you have two types of situations here. You're already given a log equals a log, In which case, if they have the same base, and only if they have the same base, will the logs cancel out. If I have multiple logs, you need to condense them with the properties, and then you should be able to cancel out the logarithms, like we've been doing on this page. And then the other type of situation is when you just have a single logarithm equals a single number. No logarithm on the right. In which case, then you would have to rewrite it as an exponential and go from there to solve. Okay? All right. This video is all done. I guess I'll see you in class. Keep working on your practice pages, okay? Bye, guys.